Let's take a look at this piecewise functions. This piecewise function, and let's do some analysis on it, like what is f of -5 and f of 0, as well as the domain and range. Hi, I'm David. I'm going to help graph linear piecewise functions. These are both linear equations. Right off the bat, we want to recognize what we have. We have a constant on top. That is one of those horizontal line constant functions. It is constantly y equal 3. So it's a big, long horizontal line where every dot on that line, the y value, is 3. I like the way they named that, so that if you say y is 3, that's true for every dot on that line. Y is 3. Remember, equals is. The next one is a linear equation. Looks like it has a y-intercept of 4, so if x is 0, that would leave the 4, and a down 2 over 1 slope, So just want to kind of recognize what we have and what we're using them for. Looks like we're going to use the horizontal line. The horizontal line for the graph of f will from -6 to -2. So I use the restriction to analyze where this graph starts and ends. I'm also noticing that it's a solid dot at -6 and again a solid dot at -2. That is, correlates with the less than or equal symbols we see there. So I'm going to go out to the first dot. That'll be at x is -6 and y, well, it's always 3. And also find the second dot where x is 2 and, well, y is always 3. So let's see if I can do that. 1, 2, 3, 4, 5, 6. I do believe this is -6. And I will start with a solid dot at the -6, 3 coordinate. I will end at the -2, 3 coordinate right here. And there is the first part of this function. The next part of the function starts at -2, but I recognize there's a hollow dot there. So I want to use that hollow dot as a starting point and then connect it with the end of the line where x is 3. So I have to do some scratch work, some evaluating. So if x is -2, in that second equation, y would be, hang on, I need to plug and chug at -2. It looks like 8. Just double checking. That would be 4. Okay, and -2 times -2 is +4. Yeah, that's definitely 8. So at -2, it is 8. And 1, 2, that's 3, 4, 5, 6, 7, 8. That would be just off the graph right there. That would be where the y value is 8 and the x value is -2. Now, I know this is a down 2 sloping graph that hits the y-intercept of 4. There's an mx plus b in there that you want to recognize. So let's take a look at that. We could keep going down until we hit the 3 dot, or we can just plot the 3 dot. Let's do that. If x is 3, and this is a solid dot, and I'm trying to find for the end of this line, there's the plug. Looks like 4 minus 6, or -2. So I'm going to go over into the x value of 3. 1, 2, 3 right there. And I'm going to go down 2 dots, 2 y values. And there is the value 3, -2. So now I just need to take a ruler out and basically just draw this line. It's fully connected. It's hard for me to draw on this board. So let me see. I'm going to get a couple of key dots here and see if I can just keep hitting them. Down 2 over 1, down 2 over 1, down 2 over 1. Looks like I hit it perfectly. Cool. And that is what this piecewise graph looks like. If I evaluate f of -5, I can do it by the function and look at the restriction. So if f of -5 falls into this first restriction, well, every answer there is 3. I could also use the function's second equation to evaluate anything between -2 and 3. That's what it says in the restriction. So if I said f of 0, that's where I would go. I also have a graph right here, and it looks like I hit 4 in the y-coordinate. Remember, it's a 4 in the y-coordinate. The domain, what x's am I using? It looks like I use every single x from and including -6 to +3. That is just moving left to right, starting at this x value at -6, making sure I hit all this ones in between, and I do. I'm looking up at the graph when I do that. I'm not looking down here. I'm looking up at the graph. I'm just showing you the x's that I'm exploring all the way out to 3. So that's just kind of how I look at that. I'm following the x's out like a width. The range, same idea. Looks like we start at lowest point. There, my lowest point for the range is right here. So it looks like I'm going to start down at, and I can be at a solid dot of a y value of -2. And it looks like I go all the way up to the 8 value. I hit every single dot on that line except 8. So I'm going to use parentheses. This is not continuous. This is what we call a jump continuity. And that's a calculus term that you just want to start getting used to hearing. But that is not a continuous graph. A continuous graph is when I graph this and I never lift my pen. And in this case, I would have to graph this with a solid dot, line, solid dot, and lift the pen right here. There's the jump. And then pick it up right after the hollow dot and come down. So that is not continuous. I hope this helps.